Intro Algebra Lesson 3-2A. We've really been working hard on solving equations and using the idea that we can transform the appearance of an equation without changing its value. We know that whatever we do to one side of an equation, we must be fair and do it to the other side of the equation. We've spent most of our time at this point adding things to one side, making sure we add to the other side the exact same amount. Or subtracting something from one side, making sure we subtract the exact same thing from the other side as well. Well, we're still going to continue that same concept as far as being fair. The only difference is we have some other transformations. We could use multiplication or division. As long as we multiply the same value on both sides, or we divide the same value into both sides, we will keep the same equality of the equation. We'll just change how it appears. Our ultimate goal is solving, which is to get the variable alone, so we're going to utilize these inverse operations. Remember, the opposite of multiplying is to divide, and the opposite of dividing is to multiply. So we can think about all of that as we go. Alright? Properties of equality. Equality means keeping things equal. There are properties of equality for addition, subtraction, multiplication, and division. What you do to one side of the equal sign, you must do to the other side. Very, very common mistake. People do not do what they do to one side of the equal sign to the other. They are not fair. And I'm imploring you, must keep things fair. Now, I realize that some of these problems could be easily solved in your head, but we really need to practice showing the work that's involved so that when the problems get more complex, we're good to go. Now, this particular problem is starting off with negative 3x equals 2. In between the negative 3 and the x, since we don't see an operation sign, is multiplication. We would like to get x completely alone. In order to get x alone, we have to get rid of that negative 3. Very common mistake is somebody goes, oh, well, I know the opposite of negative 3 is to add. Okay, but first of all, we're trying to get rid of this multiplication. Addition is not the inverse or opposite of a multiplication problem. We've got to think, what's the opposite of multiplying by negative 3? The opposite of multiplying by negative 3 is division. That line means division. What you do to one side, you must do to the other. I'm going to divide both sides by negative 3. Because now I have the exact same value on top and bottom, which means they cancel out. And I have succeeded in getting the variable alone. Now I have x equals negative 2/3. Someone might say, yeah, but that was a negative 3. Remember, you can give it to the top or the bottom. You just can't give it to both if you want it to be a negative. Opposite of multiplication is division. What you do to one side, you do to the other. You want the exact same value on top and bottom, so they'll cancel out. I didn't want to divide both sides by 2, because that would just get rid of that 2 from over there. I want to get the stuff away from the x. I want to get the variable alone. X is now over 9. We cannot forget that this symbol right here means division. Probably the number one thing people forget is that that's division. Alright, so we have a division sign here. The opposite of dividing by 9 is to multiply by 9. And the way you write 9 as a fraction is you write it 9 over 1. And if you look, you'll now have a 9 on top and on bottom that will cancel each other out. What we do to one side, we must do to the other. Now, some ask me, Corey, why did you put 9 over 1 on this side, but only 9 on that side? The reason? This looks like a fraction, has a top and a bottom. So I made my 9 look like a fraction, top and bottom. So I made sure that they were on top and bottom to cancel out. Over here, the negative 25 doesn't look like a fraction. Although you could certainly make it a fraction. You would just put it over 1. And if you did have it over 1, then this would also be over 1. So either way, it doesn't matter. You're still going to end up looking at the problem and saying, well, those 9's cancel out, so x is alone. And when I multiply the negative 25 times 9, I know a negative times a positive makes a negative. 25 times 10 would be 250. So that 9 is just one less than that, 125 less than that. It's going to make 225, so negative 225. These can both be solved by plugging the answer back in. If you take negative 2/3 and plug it in here, negative 3 times negative 2/3 is going to make a positive, and 2/3 of 3 is 2. So it actually works. Down here, if you plug negative 225 in here, negative 225 divided by a positive 9 would give you negative, and 9 goes into 225 25 times, negative 25. Alright? Last one. This is a little trickier, but it's still kind of the same. In between the negative 7/8 and the m is a multiplication sign. So we know we want to do the opposite of multiplying. The opposite of multiplying is to divide. But we've already been talked about that dividing by negative 7/8 is exactly the same as multiplying by the reciprocal. If you want to cancel out a fraction, multiply by its reciprocal. It'll go away. So we'll multiply here by 8 over negative 7. But whatever you do to one side, you must do to the other. So I make that a fraction and multiply it by 8 over negative 7. I can now do the crossing out that I needed to do so that m is alone. And here, 7 goes into itself once, so we can make it like negative 1, and into 14 twice. 8 times 2 is 16. Negative 1 times 1 is negative 1. And 16 over negative 1 is negative 16. This will take some practice. You need to train yourself to think, how do I get the variable alone? I want to use inverse operations. If I see a fraction, I know I can multiply by its reciprocal and it will cancel it out. Again, I'm not changing the value of any of these equations. I'm simply using inverse operations to change its appearance to eventually get the variable to be alone so I can isolate it and thus solve.